Hello guys, we are still on the digital clock circuit, and today we want to do a little bit of an upgrade from the NE555, which was the second generator, to Crystal Oscillator, which is more stable than the NE555. So the NE555 was working well, but it had a little, it was not that stable. It's not a very stable circuit to use for a second generator, but it worked well. So if you don't have a crystal oscillator, you can just use an NE555 in a stable mode. But if you want a more stable circuit, you can just use a crystal oscillator. So the NE555, the reason as to why we say that it's not stable, we connected a lot of external circuitry just to support it, to make it a little bit stable. That's why you're seeing our 10K port meter, which makes up the divider circuit. The 10K port meter was just to fine-tune the output in order to get a little bit of an 1 Hz oscillation. We also connected a 0.1 microfarad capacitor, which is ceramic, and near the NE555, it's connected across the voltage source and ground to make or to reduce the noise of the supply. Yes, we also connected a 0.01 ceramic capacitor right here to ground. This was also just to make the internal reference voltage to be stable. Also the output of the NE555 connected to pin number 14 of the CD4017, which is the clock input. We connected that pin to ground via a 10K resistor. This main function was to block or to allow or to allow the CD4017 not to float when the clock signal goes low. So this all external circuitry will just support the NE555 to give a 1 Hz oscillation. But today we are going to see how we can connect a crystal oscillator. How we can replace that with a crystal oscillator, which gives a more stable output. Once set, it just goes on very precise, no errors and no instabilities. So right here we have the circuitry where we have the CD4060, which is a 14-stage ripple counter, but also supports RC and oscillation circuits using the oscillator crystal oscillators. That's why you're using the crystal oscillator with it. How you connect it is just simple. You just connect pin number 9 and 10 to the 2 pins of the crystal oscillator. Then the 2 pins of the crystal oscillator, you connect each one of them to ground using a 22 picofarad. These are 22. These are 22 picofarad capacitor to ground, just for stabilization. And also one more thing, the circuit I was to buy a 32.768 kilohertz crystal oscillator, but I didn't got this in the market, so I went for a 32.00 kilohertz, which was much closer to this one, although the margin is so large, 0.768. It's a big margin, not a small margin, almost 1 kilohertz. So the reason as to why how we are going to use a 32 to be used instead of 32.768, we are going to add a 10K port meter, which is going to be connected from pin number 11 to pin number 9. So the function of the 10K port meter will be to fine tune the output in order to get a closer 1 Hz oscillation. So we are just going to connect it from pin number 11 to pin number 9. Then we are going to fine tune it to get a 1 Hz oscillation, and once set, it will just give you a stable output, no fluctuations, no instabilities. So just connect the circuit. Okay, pin number 16 goes to supply, pin number 8 goes to ground, and pin number 12, which is the reset, just goes to ground. We are not using it right now. Yeah, so it just goes to ground. When you want to use it, then you can connect BC547 just to control it. Yes, so if I can just power it on like that. and the outputs are taken from pin number 7 going back to pin number 3. So we start with pin number 7 and check. All these pins have different frequencies, so you just go checking which one is closer to one kilohertz or one has oscillation. So this one is quite fast, so we go to pin number 6. Yes, so this one is too slow, so we go to pin number 5, a little bit fast, but closer to 1 second generator. And pin number 4 actually is much even closer. So this pin number 4 is actually the one that I saw it's much closer and to work with. So once I put a 10k port meter, I'll just fine tune it and to check how the pin number 4 gives me. If pin number 4 will be closer, or pin number 4 will be exactly 1 hertz, then we are going to use it instead of the NE555 connected in a stable mode. So that's basically what I wanted you to see today. And yeah, so thank you very much guys for watching. Please subscribe to Tronics Energy, and hope to see you next time when we are going to add this circuit. We are going to add a 10k port meter to see how we can get a 1 hertz oscillation. So thank you very much guys for watching. Please subscribe to Tronics Energy and hope to see you next time. Goodbye.